Good evening, guys. Can you hear me properly? Hello. Hi. Good evening. Good evening. Good evening. Hi, Kanika. Hi, Orithro there. Hi, Lavinya. Hi, Twinkle. Okay, so today I was first, not first, rather. Hi, Kritika. Hi, Trishan. So today is not our first IOQM session or rather problem solving session. So we have just, hi, Tishika. We have just renamed it in a different way. Essentially, we have been continuing this for a long time. Very good. Anamitra, thanks for replying to this. Okay, so we also call this a problem solving session. So let's start it. And people asked that, people told me that we were doing a bit of easy problems. So that's why I've increased the difficult level of the problems so that you find it more challenging. Okay. And yeah, so let's see how it goes. I hope you will enjoy that session and I welcome all of you. I see a lot of new faces over here. So I hope you will enjoy this session. Okay. So let's start. Okay, so now you will not see my hands moving, but rather the whole screen. Okay. Hi, Joy. Yep. Good evening, Archana, Kumari. One second. Okay. So what's our plan today? Our plan today is the following. Our plan today is to do three problems rather of a difficult nature, and I will guide you through the whole procedure of the problem solving. Okay. So let's start. Hi. Okay. So let's start. Okay. So what's the first problem rather? I will share the corresponding problem with you now. Give me a second. So we have a varied topics of discussion today. Combinatorics, like permutation combination is there, probability is there, algebra is there, geometry is there. So that's a very varied sense of problem solving. The problems are really not easy, but really interesting. They are much more difficult than what we have done. So let's try to do with interesting. Let's start with an interesting one. Okay. So which one want you do first? Counting combinatorics. Which one you want to do, guys? Tell me. I will do accordingly. Okay, let's start with the combinatorics one. Okay. Let's start with the combinatorics one. Or the counting one. Okay. I don't know why my PC is hanging so much today. I'm really sorry for that. Let's see once again. It's here. Okay. Can all of you see the board? Yeah, I will do number 3 problems. No worries. I will do everything. Can you see all of you can see the problem? It's a problem is varied. Okay, it's for IOQM people mainly and also for 11, 12 people. So also for master students, whoever want to attend. Okay, the class is not specific to someone. Okay, very good. So the problem asks you. So I was taking the combinatorics class last day or permutation combination class last day. So I was telling that what exactly is combinatorics, okay? What exactly is permutation combination? So exactly permutation combination is all about counting something, okay? Counting a set. So here, I want you to identify the set is given, right? The other triplets where this certain thing hold, certain relationship hold. So permutation combination is all about counting stuff, counting the elements of a subset, number of elements of a subset, cardinality of subset. Okay. So it's a special problem over here, how to find the that corresponding subset, how to understand and count towards that. Okay, we will see this entire thing in this whole problem. Okay, yeah, that is B is a factor of A is a factor of B and A is a factor of C. B is not a factor of C. A is a factor of B and A is a factor of C. Doesn't imply B is a factor of C, right? Can you give an example, Trishan? Okay, Ayan, Tishika, and Ahana, are you here Are you here, guys? All three of you? So let's try to understand this problem. I hope all of you can see the problem. Let me make a little bit larger. Yes, that's it. So 2 is a factor of 6 and 2 is a factor of. So that's the idea. So Asha, so I'm just telling this point. These points are really good. That's why I'm telling that he's telling A is a factor of B. That means A divides B, and this is a sign of divides. Okay, this means divides. Mathematicians are lazy people, so they want to give notations. Okay, we're also lazy. That's why we are using this notation. And A is a factor of C. It doesn't imply that B is a factor of C. Okay, then B divides C. Example is 2 divides 92. 2 divides 6 does not imply that 6 divides 92. Okay. So now let's move ahead. Find the number of ordered triplets. A, B, C. So the A, B, C are positive integers and A is a factor of B. Okay. So how to approach this problem? If you don't know any theory in combinatorics, how to approach this problem? I will show you how to approach this problem from scratch. So first take an example. Always when you're given a problem, try to understand and try to approach by examples. Okay, I will give an algorithm on how to approach problems. If you don't know the theory, approach, and you will, when you approach a problem, you will necessarily understand that how to approach the problem, rather. Okay, what results you need, automatically you will understand if you approach the problem in its natural manner. Okay, in its natural flow, just like water flows. Similarly, approach the problem in its natural flow and you will get to know what results to use. Okay, do not memorize the results, and from that experiences will be coming. So don't worry about remembering stuff, just worry about approaching the problem in the right manner. So A is a factor of B and A is a factor of C, and A plus B plus C is equal to 100. So approach by an example. Find a few examples. Can you give me a few examples as that it holds? How can you approach by example? Yeah, this is easy. Yeah, right. So we can take that, right? So first, whenever this information is given, that sort of like instantly prompts us to take that. Okay, B is equal to some AP and C is equal to some AQ. Okay, we can take that. We can instantaneously take that. Okay, so therefore A plus B plus C is equal to 100 changes to A times, okay, A times 1 plus P plus Q is equal to 100. So since there are a lot of varied people over here, so I'm just taking a bit of time to explain every step. Yeah, perfect. So whenever given this problem, what's the next step? The next step to use the information that A is a factor of C. So this implies what? This implies that A divides 100, right? So try to understand that. So we have varied number of solutions. So what is the algorithm now? How to approach this problem now? So what we have got till now, let's try to understand it. We have A plus B plus C is equal to 100. Replaced and used the information that we replace A plus B plus C is equal to 100 to A times 1 plus P plus Q is equal to 100. Okay, where all of them are integers. That's the first step. Now the second step of the algorithm of the solution is this. It asks you that what? It prompts you to take A divides 100. Now what you do? If A divides 100, what exactly do you do? So let's take that. Let's take that it implies that A is equal to A times K is equal to 100. Okay. So therefore we get the new equation format. We are just replacing the variables. You will see why we are replacing the variables. Okay. You may be overwhelmed by the number of variables over here, but let's see how it works out. So it's 1 plus P plus Q. The 100 equal to AK. It will turn out to be this, right? All of you got this equation? All of you understood this? All of you understood this step? Yeah, you're right. So therefore observe that K is also a factor of 100. Okay. And if A is a factor of 100, if and only if K is a factor of 100, right? A factor of 100. A is a factor of 100. So therefore, this implies that we need to take different factors. So let us write down all the factors of 100. This promptly implies us. See, this is just like of the solving the problem is just like a flow, right? We are like going the flow of the problem. So K is a factor of 100. So let's list down all the factors of 100. Okay. Factors of 100. The set is first is 1, then is 2. Guys, you tell me. No, we didn't assume. See. What we got this equation, right? Then what it implies? 1 plus, so it 1 A into some integer is equal to 100. That means A must divide 100, right? A is equal to A is in and some integer is equal to 100, right? That means A divides 100. We didn't assume it. Yes. So 1, 2, 4, 5, 10, 20, 25, 50 and 100. Perfect. So let's write it down. 1, 2, 4, 5, 10, 20, 25, 50, 100. Perfect. So that means what? That means 1 plus P plus Q will be equal to these values. That means P plus Q must be equal to 0, 1, 3, just 1 minus this, 4, 9, 19, 24, 49, 99. All of you understood till this step, guys? Tishika, Ayan, are you understanding? Yeah. So what's next? So therefore, the problem reduces down to what? The problem reduces down that how can we solve. So try to observe the pattern of the solution, like the movement of the solution. First we did this when we got that a is a factor of 100. Then we got into a new equation, and then we got into p plus q is equal to this set of numbers. So therefore, it reduces down that how to solve p plus q is equal to some alpha. This set of positive integers, p and q are positive integers, belongs to natural number. Set. How to solve this problem? Okay. So it's really easy. There is a general algorithm. Okay. There's a general algorithm called ball and stick method. So if you go to our YouTube channel, there's a lot of videos on this. Okay. It's called ball and stick method. If you go to our YouTube channel, this YouTube channel, if you subscribe to it, if you go to the place, you will find a lot of this. But we are doing an easier version of it. Okay. That is p plus q is equal to alpha. So what p can take? So if p can take 1, q will be taking alpha minus 1. Okay, and alpha will be greater than or equal to 1, obviously, because p and 2. Okay, and p can be taking, p is taking 2, then alpha must be, q must be alpha minus 2 dot dot dot. It can go up to alpha minus 1, and here it's 1, right? This set of numbers, how many solutions are there? Total alpha minus 1 solutions are there, right? So therefore, it has alpha minus 1 solutions, right? Therefore, this has no solution over here. This has no solution. It will start with 3. So for 3, it will have, the following. For 3, it will have number of solutions 2. For 4, it will have 3. For 9, it will have 8. For 19, it will have 18. For 24, it will have 23. For 49, it will have 48. And for 99, it will have 98. Okay, so it's sum of all these results now. Which step you want to me to explain, crazy gamer? All of you understood this, guys? What I'm trying to do? Any doubts? Which step you didn't understand? So I'm telling you the steps of approach, guys. Okay, try to understand it very carefully. So we have shown you that we are following these steps, and this is the last step, that for each one of them we have deleted this 2. For each one of them we have got this alpha minus 1 solutions. Okay, we have shown this how it comes up. So therefore we have got that it has 2 plus 3 plus 8 plus 18. You count this up, sum this up, you will have that many solutions. Okay, guys. Okay, the ball and stick method, please see it in our video. I will give the link over here. But try to understand this. We are trying to say p plus q is equal to alpha. These solutions, okay, where p or q are natural numbers. Twinkle, okay. And so therefore, if p takes 1 value, then q must take alpha minus 1 value. If p takes 2 value, q must take alpha minus 2 values. Now p can go up to alpha minus 1 and q can go up to 1, right? So therefore, exactly alpha minus 1 pairs of solutions are there. Do you understand it now? Exactly alpha minus 1 pairs of solutions are there. Twinkle, did you understand? Ayan and Tishika, did you understand? Since it's a first class. Okay. Great. Nice. So therefore, We have therefore P plus Q can take values 3, 4, 9, 19. So we have got this general one. So suppose we, instead of this giving 100, we give you that A plus B plus C is equal to any number n with the given condition A divides B and A divides C. Prove that the same, by applying the same principles, prove that the number of solutions will be summation of, can you tell me what it will be? D minus 2, is it 2, P plus Q minus 1, yeah. D minus 2 where D divides n and D is greater than or equal to 3. Yes. Yeah, this is the idea. So it is summation of D minus 2, D divides n and D is greater than or equal to 3. For general n. Now your homework is to do the following problem. Your homework is to do the same problem for summation of alpha I from 1 to n is equal to Jn, where alpha 0, alpha 1 divides alpha j for j not equal to 1. Okay. Then find the solutions. Okay, find the number of solutions for the general one. Okay. So if you can do this, then this part of the ball and stick method will be totally fine. Okay. Now let me search in the YouTube for our corresponding link to the problem, link to the ball and stick method. Just give me a minute so that I can share it in the WhatsApp chat. It's a really important aspect of combinatorics and probability combinatorics and one second. Probability combinatorics and permutation combination. So, yeah, 1 second, just check. So, open yes. So, yeah, I got it. It's through a problem rather. You can see similar problems out there in our YouTube channel. See this corresponding video, not now, but I'll save it later for your purpose. A WhatsApp group of what, Twinkle? Okay, so let's move on to the next problem, guys. So all of you understood, and please do this homework problem to make your understanding much more rigorous and much more with clarity. Okay, let's move on to the next problem, guys. What's the next problem? Let's see. I love this problem. It's a big problem, but I really love this problem. Okay, let's see. It's a big problem, so it will take a lot of space. Okay, that's our blackboard. Yeah, all of you can see the problem, guys. All of you can see the problem. Maybe I will make it a little bit bigger for you to see. Let's see it, okay? Okay, so a triangular array of squares has one square in the first row 2 in the second row, and in general k squares in the kth row. With the exception of the bottom row, each square rests on the other 2 squares immediately. The square of the 11th row. So there are 11 rows over here. Let's check it. First row, second row, third row, fourth row, fifth row, sixth row, seventh row, eighth row, ninth row, 10th row, 11th row. So the numbers are each numbers is in each number of square of the 11th row. So each 0 or 1 is placed. Okay, 0, 1, 1, 0, somewhere it is placed. Okay, here are only 0 and 1 in this last one. Now the question is asking for how many initial distributions of 0, 1. So what is done is that in the next square here is the sum of these 2 squares. Okay, next square here sum of these 2 squares, and this continues like this. For which distributions of 1s, of 0s and 1s, this top number is a multiple of 3. It's a really beautiful problem. I love this problem. For which distributions of 0 and 1 in the bottom column, this number is the above top number is a multiple of 0 and a multiple of 3. All of you understood the problem, guys? Yeah, all of you understood the problems? Yeah, I am very happy because I love this problem. Because I did this problem when I was your age. That's why I'm happy. So my childhood days with mathematics suddenly popped up in my mind's eye rather. Okay, so did you understand the problem, guys? It's a hard problem. It will take some time to understand. It will take some time to solve, but I will help you out through the process entirely. So yeah, you're giving 0 and 1 in the bottommost row, and you're adding this 2 row or 2 like you're adding the 2 squares to get to the number in the 2 squares to get to the above square. Okay, and then we continue this process till we go to the top square, which contains a number. So for which 0 and 1 distribution, the top square will be the corresponding bottom wala squares. So which distributions for which distribution it will be 3, the multiple of 3 rather. That's the question. Ayan Tishika, did you understand? Okay, so think about it a bit. That's a good approach. Let's try to do the problem. Okay, let's try to do the problem. So how will you do it? Just let's assume that the lowermost low is x11. I need some space over here. Let's write it down in this manner. x1, x2. I'm just changing the x3 because there is a lot of space over here. x4, x5, x6, x7, x8, x9, x10. Okay, let's try to see what will be here. It will be x1 plus x2. Here it will be x2 plus x3. So the first step in solving this problem is just assume that the algebraic form. Okay, then we will see the pattern out here. So don't be panicked when you see these problems. Okay, don't be panicked. Just focus on how to approach this problem, nothing else. So just assume in the algebraic setup, we are setting up the general stuff. We will see how many such distributions it will happen. x3 plus x4, then x4 plus x5. This is always the first step. Even if you don't know a problem, try out with examples, try out with basic algebraic representations and see for which it is coming up. Okay, x6 plus x7. So I'm writing this up. There's a reason behind it. I will do it up till 3 levels and you will see the pattern together. Okay, Mathematics is all about discovering patterns, guys. Okay, so that's the idea you must always look for. Seek patterns wherever you can. That's the beauty of mathematics and all mathematics related topics. So let's do this. So here it will be x1 plus twice x2 plus x3. Here it will be x2 plus twice x3 plus x4. Here it will be x3 plus twice x4 plus x5. Here it will be x4 plus twice x5 plus twice x6 plus x6, sorry. Here it will be x5 plus twice x6 plus x7. Okay, here it will be x6 plus twice x7 plus x8. Here it will be x7 plus twice x8 plus x9. Here it will be x8 plus twice x9 plus x10. Here it will be x9 plus twice x10 plus x11. Okay, let's do it as a next step. Yeah. So let's do it again from now. So these are small squares. Remember, these are the small squares. Now these are the big squares. Not the big squares, just the above squares. Okay, since they look big algebraically doesn't mean they're big. It's just a number. And then there's these squares. I just drawn it horizontally, okay? Since the algebraic equations will be larger. And now next what? Let's see this now. If you add this up, you observe that it's x1 plus thrice x2 plus thrice x3 plus x4. Here it will be x2 plus thrice x3 plus thrice x4 plus x5. Here it will be x3 plus thrice x4 plus thrice x5 plus x6. Here it will be what? x4 plus thrice x5 plus thrice x6 plus x7. Okay. Here it will be x5 plus thrice x6 plus thrice x7 plus x8. It continues. Okay, all of you understanding? Exactly, Tishya. So all of you understanding what is happening over here, guys? Can you see the pattern? Now add these things up now. I will not go much ahead because there is no place, rather. Can go at most another step. Let's focus on that step mainly. Here it will be x1 plus, observe that it's 4x2 plus what? 6x3 plus 4x4 plus x5. Here it will be x2 plus 4x3 plus 6x4 plus 4x5 plus x6. Okay, you do another thing, you will get. So what exactly you're getting, guys? Okay, all of you see, observe, saw a pattern. Initially the coefficients, so essentially in every box from the lower or the whatever row it is, in every box can be represented as sum of, so it's like this: alpha 1, 1. So now let's say every box in rth row, there are 11 rows. The rth row can be represented as, say, alpha 1, or let's say a 1 1 1 r, say, or say r1 x1 plus a r2 x2 dot 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 a r 11 x 11. Okay, so so these are the sort of coefficients, right? For example, so in this corresponding box, right, this is every box is of this form. Okay, so it depends upon which row it is. And observe this in rth row. Okay, essentially these coefficients are sort of focused around, say, in rth row, it's sort of in the first row, it was what? You were seeing the, in first row, it was sort of only one. The second row, it was sort of 1, 2, 1 coefficients, okay, set of coefficients. The third row, it was sort of 1, 3, 3, 1. The fourth row, it was sort of 1, 4, 6, 4, 1. Okay. Among such corresponding, I think it is, I'm using a pen tab, Imran. Actually, this board is a bit more like jerky sort of thing. Actually, I'm using a pen tablet. I'm sorry for the inconvenience. No, I'm just using this. So therefore, observe in the second row, it is as coefficients are sort of the form a plus b whole square ka coefficients, right? 1, 2, 1. It is a plus b whole to the power 1 ka coefficient. It is sort of a plus b whole cube ka coefficient. Okay, it's a plus b whole to the power 4 ka coefficients. So therefore, if you continue like this, in the 11th row, it will be a plus b whole to the power, in the first row rather, I mean from the bottom, the 11th row, it should be sort of, oh, I am so sorry. I think there's some mistakes over here. Yeah, I missed this row. Yep. The first row is sort of 0, and then I missed this. Yep. This one. Yep, you're right. So first is 1, then there is 1, 1. Okay, you see that? So therefore, the first row is a plus b whole to the power 0, and the second one is a plus b whole to the power 1, and then this. So essentially, for rth row from the bottom, the coefficients are same as the coefficients of a plus b whole to the power r minus 1 ka. So therefore, for the 11th row from bottom, the coefficients will be of the form a plus b whole to the power 10. Okay. Extremal graph theory can be done from books. There are lots of books over there. Okay, so now what's the idea? What's the idea now? So therefore, the coefficients over here, what will be the term? So therefore, our aim is to find the last term, the term in this corresponding framework, or in this last top term. Can someone tell me essentially it will be of this form? It will be summation of 11 choose, it will be looking like this. 11 choose 0 x1 plus 11 choose 1 x2 plus dot 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 11 choose 11. Sorry, it should be 10. I'm so sorry. 10 choose 10. x11. This will be the element in the first term. So this is a lemma or result. This is what we have proved. So I can give a rectangle over here. So it's an element in the top box number. All of you understood this? Why top box number is this? All of you understood this? Why top box number is this? Oh, that's what I told now. Observe this very carefully. In the first row, it is the coefficient is 1. In the second row, the coefficient is 1, a plus b whole to the power 1 ka. The first row coefficient is a plus b whole to the power 0 ka. In the second row, it's a plus b whole to the power 1 ka. In third row, it's a plus b whole to the power 2 ka. Okay. And in the fourth row, it's a plus b whole to the power 3 ka. So therefore, in the 11th row, it will be what? A plus b whole to the power 10 ka coefficients, right? Correspondingly. And it matches because there are exactly 11 terms out there. So, and there are 11 coefficients in a plus b whole to the power 10. Yeah, we can surely write that, but you know, like understanding and seeing the pattern is much more joyful than just directly going by induction. You may see it, do it quickly, but the class is all for all the people. So I should tell them how I approached it, okay? Rather than seeing the whole thing. And it's actually provable by induction. But more importantly, the pattern recognition is much more important. The proof is a different aspect. I will surely do the proof. The proof is really easy, but by induction. But understanding the whole thing is much more important. How the pattern is evolving. That's a much more beautiful part of mathematics, right, Kanishk? So you can surely prove it and send it to me in Skype. I will check it. It's really easy, the induction proof. Yeah, the proof essentially follows on induction, okay? If someone can prove it, it will be really good. But understanding the pattern and seeing the pattern is much more important. Proof comes automatically. You will know how the proof comes. Okay, Tishika, did you understand? Ayan, did you understand? All of you understand? Tishwa, did you understand? All of you understood this? Any doubts? So therefore, we have to, the question therefore sorted down that so now xi either belongs to 0 or 1. For how many distribution of xi's? Okay, this summation of 10 choose I from 0 to 10, xi plus 1 is divisible by 3. This is the problem now. So we have changed. So this is the idea of any mathematical problem, guys, okay? The idea of any mathematical problem is to transform the present framework of the whole story of the problem into mathematical framework, okay? Now, once you do it, what happens is the following, that it's much more approachable mathematically. So first you play with the problem, you do the play around and essentially playing, and the algebraic part of it is to make the problem much more mathematical. So we have got a mathematical format. Now what we will do, we will now use theorems now, okay? We will now use results to understand and approach the problem. the expression of the mathematics is the most important part. That's the most creative part. Now, when you have results and problems and results in your arsenal of solving, then you approach the problem in the most beautiful manner and use those results and use those theorems. Okay, even if you don't know, you will slowly understand how the results are applicable. Okay, but the most beautiful part of this is to understand how it works, to formulate this part. Okay, any doubts till this point, guys? Now we will solve this problem rather than the other problem. Okay, so let's try to see. So this is a problem now. Very good. So how the zeros and ones are correspondingly suited over here. Which distributions of zeros and one we will see rather. So we have got this formula over here. Let me give a interesting format of this. Good looking format rather, unlike my handwriting. Okay, so we have to find the corresponding x and zeros, x naught and x ones. So tell me now. So first of all, what is the idea? Now the beautiful idea is that what do we do next? We just check. So let's try to find out this number. This is 10, right? This is 1, sorry. Let's see the coefficients. This is 10. This is 45. 3 divides this number. That's what we are trying to focus on. 3 divides this number. Okay, 10 x1 x naught plus x1 10 plus x2 plus again x10. Observe that this automatically cancelled, right? Because 3 divides that. So this automatically, so essentially we need to see that for which coefficient. So this automatically turns out, find, the next top part is asking that find I such that 10 choose I is divisible by 3. Find all such i's. Okay, that's the next part. That automatically, it's natural, no? Oh, yeah, it should be x1. Actually, yeah, where I've written it formally, it should be I. You're right. It should be x1. So observe this, therefore we are sort of seeing those numbers for which it is divisible by 3, okay, because it reduces the problem. See, the mathematicians, as I told, are lazy persons. So you will, every time you must try to reduce the problem in an easier version, okay. It's actually the rule in general. It's actually how human minds work, okay. We try to simplify problems. We try to do stuff that we already know, okay. That's why. So therefore, we are already trying to reduce the problem to easier version. So find all such i's such that it is divisible by 3. Why? Because we'll eliminate that and we'll take those which is not divisible by 3. Okay, so let's try to prove it. It's really easy. So 10 choose I is divisible by 3 for all I greater than equal to 2 and less than equal to 8. Yes. 10 choose 1. 10 choose 1 and 10 choose 9 is not divisible by 3, right? So observe this. What is 10 choose to 1 I, guys? It's simple. 10 choose I means 10 factorial in 10 into 9. What is 10 choose I? 10 factorial by I factorial into 10 minus I factorial. So you can sort of write it as 10. Okay, 10 into 9 into dot 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 10 minus I plus 1 divided by I factorial. Okay, so prove that this is only divisible by 3 for all 8 greater than for all these numbers. Okay, can you prove it? Why it's true? Can you tell me why it's true? How can you prove it mathematically? How can you prove it mathematically, this thing? So 10 choose I, this is the result. 10 choose I is divisible by 3 for I less than equal to 8 and greater than equal to 2. Why? How can you prove it? So this is an idea of reconciliation. So I'm trying to connect various parts of mathematics together. So that's the idea of problem solving. Okay, it can be done by other methods, but I'm deliberately choosing different methods because you will learn newer ideas over here. Okay, these are very important principles in problem solving of mathematics. So you must focus on this. So let's try to understand. So observe 10 choose I and the 10 choose I minus 1. How they are related? I plus 1 rather. So 10 choose I is 10 factorial by I factorial into 10 minus I factorial. Okay, and 10 choose I plus 1 is 10 factorial by I plus 1 factorial by 10 minus I minus 1 factorial. Okay, so if you divide by this, what will you get? You get cancelled, and here you get I plus 1 by 10 minus I. So what do you get? 10 choose I plus 1 is actually 10 choose I times 10 minus I by I plus 1, right? So that's the idea. All of understanding? Not product of I consecutive numbers, that will not work because that is divided below by I factorial. Okay, we cannot really show that. Okay, so suppose this is divisible by, so let's try to understand. 10 choose 3 is therefore 10 choose 2 times what? 8 by 4, 8 by 3. Okay, 10 choose 4 is therefore 10 choose 3 times 6 by 5. Okay, so we have to specifically check for I is equal to those numbers for which divisible by 9, divisible by 3. Okay, then it can cancel out the upperpala 3, right, if it's there. So essentially, if this is divisible by 3 now, so we will see that the denominator of this is not divisible by 3. So we have to check for I is equal to 2, I is equal to 5, and I is equal to 8 for these numbers only. Okay, and you can check for these numbers that they're actually divisible by 3. Okay, that's really easy because 10 choose 2 is same as 10 choose 8, so this must be divisible by 3, you know. Now just it's about 10 choose 5. All of you understood the method? Yeah, right, Sinja. You're right, Sinja. So essentially, we are doing that in that manner. But this is our idea of question. How do you find an algorithm to do it? So a general homework problem for you to do is find m, choose n, find an algorithm, find all m and n such that m choose n is divisible by 3. Where n is less than equal to m and n is greater than equal to 0. Okay, find all such m and n. It's a very interesting problem. In 10 choose yeah, you're right, 7 by yeah, you're right, I'm so sorry, you're right, Dishika. Yes, so therefore you can understand that this is an integer, right, and this is divisible by 3. So the 3 can cancel only if this is not divisible by 3, right? If this is divisible by 3. Therefore, you have to take extra scrutiny, do extra scrutiny for these 3 numbers, okay? So therefore, we got convinced that for all 8, for all such numbers, it's divisible by 3, right? We got convinced that. So therefore, we just change those numbers. We just remove those numbers. So what do? We therefore will take this 0, 1 and 9 and 10. So therefore we must check for, therefore reduces down the following problem, that 3 divides 10 choose 0 plus 10 choose 1, 10 choose 0 x1 plus 10 choose 1 x2 plus 10 choose 2 x9, 10 choose 9 x9, and I'm so sorry, am I doing something wrong? No, it's totally fine. 10 choose, this will be 10 plus 10 choose 10 x11. So it can be written as 3 divides x1 plus 10 x2 plus 10 x10 plus x11. Okay, it's a long problem, it's a very beautiful problem. So therefore what we get from here, we get that, but these are problems will come in IOQM, okay, but in any portions. So observe that you just you can replace this 10 as 9x2 plus 9x10 plus x1 x2 x4. So that is x1 plus x2, because 9 is the common part, you divisible by x10. Okay, so therefore we can find solutions to this. How many solutions to this? So therefore what we have got that, okay, that means 3 divides x1 plus x2 plus x10 plus x11, and the rest, that is x3 dot 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 x9, can be anything. So here we will use a multiplication rule of combinatorics. Yes, that means this can take values 0, 3, 6 and 9. Okay, this can take values 0, 6 and 9, but observe that it cannot take 6, it cannot take 9. Okay, because maximum this is less than equal to 4 and greater than equal to 0. So therefore it can only take 0 and 3, right? Because each of them are either 0 or 1, right? So therefore we get that x1 plus x2 plus x10 plus x4 is 0, and x1 plus x2 plus x10 plus x4 is x10 plus x11, sorry, is equal to 3. Observe that there are 4 solutions here and there is only one solution here, all zeros. And here there are 4 solutions, 3 ones and 1 0. Okay, so therefore 5 solutions over here into this region. Rest of all of them can take either 0 or 1 values. So 2 to the power 7 such cases. So the number of solutions is 5 into 2 to the power 7. 10 to the power 7? How can it be 10 to the power 7? X3 can take, these of the things 0 or 1 values, okay? All of you understood? All of you understood? Any doubts? Tishika, Ayan, others, all of you, any doubts, guys? All of you understood? All of you understood? Any doubts? So it's a beautiful problem, right? A long problem. We did it step by step. So I will revise it once again, the whole steps. So first we understood the pattern. Okay? By examples, pattern of coefficients. Then we found out the last box value. That is summation of tan choose I xi plus 1. Then we found out that 3 must divide this. Then we found out what? That which 3 divides tan choose I for I less than equal to 8 and greater than equal to 2. This implied that 3 must divide x1 plus 10x2 plus 10x8 x10 plus x11. This gave that 3 must divide x1 plus x2 plus x10 plus x11. And this gave that this number of solutions is 5 and into rest is 2 to the power 7. Sure. So observe that since xi is 0 and 1, so the values it can take is 0 or 3. Since it's multiple of 3, right? It's 0 or 3. If it's 0 and all are 0 and 1, it can only one solution be there. All are 0. Therefore, is the one solution over here. And if it takes 3, that means what? Each of them are 0 or 1 either. So if it's take 3, it can only be 3 ones and 1 0. So that is 4 solutions. Okay, that's it. You understood, Tishika? All of you understood? Any doubts? Very good. Okay. So good night, guys, and see you in the next class with other beautiful problems. So be prepared to get this set of problems in IOQM. Okay. This will be long yet interesting. Okay, this is an RMO problem converted into IOQM problem. Okay, bye bye, good night, and see you in the next class. 3 doesn't divide 10, choose 1. Why will 3 divide 10, choose 1? It's 10 and I'm dividing into 9 plus 1. 9 is the part, so therefore that part is. Why I have written this statement, Rajvardhan? Please go and check the recordings, okay? I have not written that statement. Okay, bye.